Directions for this section: find each limit using L'Hopital's rule when applicable. Make sure you show why L'Hopital's rule is applicable if you use it. All right, first of all, number 5, in order to get this to turn out the way that I really want it to turn out, I do not want this 2 here. So if you would just scribble off the 2 and pretend like it is not in the problem anymore, that would be great. Okay, so we're going to find the limit as x approaches 0 of x minus ln of 1 plus x over x squared. Well, we know our first thing is just to go ahead and plug in 0. So I'm going to get 0 minus the natural log of 1 plus 0 over 0 squared. Natural log, this would give me 1. The natural log of 1 is 0. 0 minus 0 is 0 over 0 squared is 0. That sets me up that I may use L'Hopital's rule now. Okay, so it's going to be the limit as x approaches 0. We're going to take the derivative of the numerator. The derivative of x is 1. And then minus the derivative of ln would be du over u. This would be our u. So our du would be 1 over our u would be 1 plus x. And then all over the derivative of the denominator would be 2x. All right, and so let's go ahead and try to plug in 0 again. I'll get 1 minus. If I plug in 0, 1 plus 0 would give me 1. So I'm going to have 1 minus 1, which is 0. And then in the denominator, I'm also going to have 0. So once again, I get to use L'Hopital's rule. So we'll have the limit as x approaches 0. We're going to take the derivative again. The derivative of 1 is 0. The derivative of this is like negative 1 plus x to the negative 1. When we're taking the derivative of that, we're going to bump the negative 1 out front, so that's going to become a positive 1. 1 plus x to the negative 2, because we're going to subtract 1 from our power. And we would need to multiply by the derivative of what's in the parentheses, but since that's just 1, I don't need to worry about that. And if I wanted to rewrite that, that would be rewritten as 1 over 1 plus x squared. So we are going to have 1 over 1 plus x squared all over. The derivative of 2x is going to be 2. So now if I go to plug in 0, if I plug in 0 for my x, I'm going to get 1 in the numerator, and then I get 2 in the denominator, so my limit is 1/2. Number 6, find the limit as x approaches pi. So the first thing again I want to do is plug in pi. So I get the cosine of pi over 2 over pi minus pi. The cosine of pi over 2 is 0. Pi minus pi is 0, so I definitely get to use L'Hopital's rule. So now I'll be finding the limit as x approaches pi. The derivative of cosine is going to be negative sine of pi over 2, but it's going to be multiplied by 1/2 on the outside because I do have to take the derivative of the pi over 2. And then over the derivative of x minus pi is just going to be 1, because the derivative of x is 1. The derivative of pi, because it's a constant, will be 0. So now we're going to go ahead and try to plug, actually this should be x, sorry about that, x over 2. Now from here we do want to plug in pi. So now if I plug in pi, I'll get negative 1/2 sine of pi over 2 over 1. The sine of pi over 2 is 1, so my limit will be negative 1/2. All right, the next one, the limit as x approaches infinity of 1 plus 3x to the x. The first thing I want to do, of course, is plug in infinity. So I'm going to get 1 plus, if I plug infinity in there, I'm just going to get 0, and x will be to the infinity. This gives me 1 to the infinity, which is an indeterminate form, so I know I'm going to somehow be using L'Hopital's rule. And if we have a power, we generally take the ln of both sides, so I'm going to make this say y equals the limit, so then I'm going to take the natural log of both sides. The natural log of 1 plus 3 over x to the x. And then remember, we're allowed to bump that x out front. So I'm just going to bump that out front. And then from here, this is not set up to do the L'Hopital's rule right now because it's not a fraction, but we can make it into a fraction by moving this x down to the denominator. So it's going to be the same as limit as x approaches infinity of the natural log of 1 plus 3 over x over 1 over x. Okay, now I get to see if L'Hopital's rule might apply. If I plug in infinity, I'll end up getting the natural log of 1, which is 0, and then 1 divided by infinity will also be 0, so I do get to use L'Hopital's rule now, which is very nice. Okay, in the numerator, since I have an ln, it's going to be du over u. So the derivative of the numerator, the derivative of 1 is just nothing. The derivative of 3 over x is negative 3 over x squared over my u. And then all over the derivative of the denominator, the derivative of 1 over x will be negative 1 over x squared. Okay, and then I notice this and this can cancel except for the 3 will not. So this will end up being 3 over 1 plus 3 over x. And now if I plug in infinity, I'll get 3 over 1 plus 0, which will reduce to 3, which now shows me that the natural log of y was equal to 3. Now I have to do the logarithm loop, so I will end up getting that y equals e to the third power.